NEC Article 820.40 outlines the requirements for cable grounding at the house box. According to the NEC, cable armor or braid shall be grounded at every accessible point where the armor is exposed or attached to conductive equipment. Cable grounds at house boxes and other accessible points shall be made using approved methods. For RG-6 and RG-11 coaxial cables, there are several approved grounding methods. Firstly, a grounding block, which is a metal or composite block with threaded connections for attaching the cable braid to ground. Secondly, a grounding clip, which is a metal clip with a screw that fits over the cable braid and connects it to a grounding lug or conductor. Thirdly, a grounding connector, which is a mechanical connector that crimps or pierces the cable braid and connects it to a ground wire or lug. When installing the grounding connection, the cable braid shall be scraped clean before making the connection. The grounding connection shall be tight and secure. All conductive components connected to the grounding system shall be bonded together. A premises bonding jumper may be required to bond the cable grounding block to the building's grounding system, such as the electrical service panel or ground rod. The point where the cable enters the house box should be sealed with a watertight sealant to prevent moisture intrusion. In areas prone to lightning strikes, additional grounding measures may be necessary, such as installing a lightning arrestor on the cable entrance. It is important to consult with a qualified electrician for proper grounding installations and to ensure compliance with all applicable codes and standards. The grounding block is a key component. It serves as the primary interface between the coaxial cable shield and the building's grounding system. Typically constructed from metals such as copper or brass, or a durable composite material, it provides a low impedance path for unwanted electrical currents to safely dissipate to ground. The block features threaded connections, allowing for secure and reliable attachment of the cable's braid or shield, as well as a grounding conductor. This ensures continuous electrical conductivity, minimizing the risk of electrical shock or damage to equipment. Installation of the grounding block typically involves the following steps. Firstly, selecting a suitable location for the grounding block. This should be an accessible point near the cable entry, such as a house box or service panel. Secondly, preparing the coaxial cable by carefully removing the outer jacket and exposing the braid or shield. Ensure that the braid is clean and free from any corrosion or contaminants. Thirdly, attaching the cable braid to the grounding block using the threaded connections. Tighten the connections securely to ensure good electrical contact. Fourthly, connecting a grounding conductor from the grounding block to the building's grounding system. This may involve connecting to a ground rod, the electrical service panel, or another designated grounding point. The grounding clip provides an alternative method for grounding coaxial cables. It consists of a metal clip, often made from copper or steel, that is designed to fit snugly over the cable's braid. A screw or other fastening mechanism is used to secure the clip in place, ensuring a tight electrical connection. The clip also features a grounding lug or conductor, which allows it to be connected to the building's grounding system. The grounding clip offers a convenient and cost-effective solution for grounding coaxial cables, particularly in situations where space is limited or where threaded connections are not feasible. Installation of the grounding clip typically involves these steps. Firstly, selecting a suitable location for the grounding clip, similar to the grounding block. Secondly, preparing the coaxial cable by exposing the braid or shield. Thirdly, positioning the grounding clip over the braid and tightening the screw or fastener to secure it in place. Fourthly, connecting the grounding lug or conductor to the building's grounding system. The grounding connector offers yet another option for grounding coaxial cables. This type of connector utilizes a mechanical mechanism to crimp or pierce the cable's braid, establishing a direct electrical connection. Grounding connectors are available in various designs, including compression connectors and punch-down connectors. They are typically made from metal such as copper or brass, and are designed to provide a reliable and long-lasting grounding solution. The grounding connector offers a versatile and efficient method for grounding coaxial cables, particularly in high-volume installations. Installation of the grounding connector typically involves these steps. Firstly, selecting a suitable grounding connector that is compatible with the coaxial cable being used. Secondly, preparing the cable by stripping the outer jacket and exposing the braid. Thirdly, inserting the cable into the connector and using a crimping tool or punch-down tool to secure the connection. Fourthly, connecting the connector to a ground wire or lug, which is then connected to the building's grounding system. Regardless of the grounding method used, proper installation techniques are essential to ensure a reliable and effective grounding connection. The cable braid must be scraped clean before making the connection. This removes any corrosion, oxidation, or other contaminants that may impede electrical conductivity. A wire brush or abrasive pad can be used to clean the braid thoroughly. The grounding connection must be tight and secure. Loose or corroded connections can create resistance, reducing the effectiveness of the grounding system and increasing the risk of electrical shock or damage. All conductive components connected to the grounding system must be bonded together. This includes metal enclosures, equipment housings, and other conductive elements. Bonding ensures that all parts of the system are at the same electrical potential, minimizing the risk of voltage differences and stray currents. A premises bonding jumper may be required to bond the cable grounding block to the building's grounding system. This jumper wire provides a direct electrical connection between the cable grounding system and the building's main grounding system, ensuring that both systems are at the same potential. The size and type of bonding jumper required will depend on local electrical codes and the specific characteristics of the installation. The point where the cable enters the house box should be sealed with a watertight sealant to prevent moisture intrusion. Moisture can corrode the grounding connections, reducing their effectiveness and potentially creating a safety hazard. Sealing the cable entry point helps to protect the grounding system from the elements and ensure its long-term reliability. In areas prone to lightning strikes, additional grounding measures may be necessary. Lightning can induce high-voltage surges in coaxial cables, which can damage equipment and pose a safety risk. A lightning arrestor can be installed on the cable entrance to divert these surges to ground, protecting the equipment and the building's electrical system. It is important to consult with a qualified electrician for proper grounding installations and to ensure compliance with all applicable codes and standards. The electrical codes vary depending on the location and the specific application. A qualified electrician will be familiar with the applicable codes and can ensure that the grounding system is installed correctly and safely. The NEC provides comprehensive guidelines for grounding and bonding electrical systems. Article 820 specifically addresses the grounding of coaxial cables. This article outlines the requirements for grounding cable shields, equipment enclosures, and other conductive components. It also specifies the acceptable methods for making grounding connections and the minimum size of grounding conductors. Adherence to the NEC is essential to ensure the safety and reliability of electrical systems. In addition to the NEC, local electrical codes may also apply. These codes may impose additional requirements or restrictions on grounding installations. It is important to consult with the local electrical inspector to determine the specific requirements for a particular installation. Proper grounding is essential for protecting people and equipment from electrical hazards. A well-designed and properly installed grounding system provides a low-impedance path for fault currents to flow to ground, tripping circuit breakers or ground fault circuit interrupters, and preventing electrical shock or damage. Grounding also helps to reduce electrical noise and interference, improving the performance of electronic equipment. A grounding system should be inspected and tested regularly to ensure that it is functioning properly. Grounding connections should be checked for tightness and corrosion, and grounding conductors should be inspected for damage or deterioration. A ground resistance test can be performed to verify that the grounding system is providing a low impedance path to ground. Any problems with the grounding system should be corrected promptly to maintain its effectiveness. Understanding the NEC standards for cable grounding at the house box is crucial for ensuring the safety and reliability of electrical systems. By following the guidelines outlined in Article 820 and consulting with a qualified electrician, you can ensure that your cable grounding system is properly installed and maintained. This will help to protect people and equipment from electrical hazards and improve the performance of electronic equipment. The correct installation of a grounding system for coaxial cables involves several critical steps to ensure safety and compliance with electrical codes. Firstly, identifying the grounding point is essential. This is typically a metallic cold water pipe, a ground rod, or the building's main electrical grounding electrode. The grounding point must provide a low impedance path to earth, allowing fault currents to safely dissipate. Secondly, selecting the appropriate grounding hardware is important. This includes grounding blocks, clamps, and conductors that are specifically designed for coaxial cable grounding. The hardware should be made of corrosion-resistant materials and be listed for the intended purpose. Thirdly, preparing the coaxial cable involves carefully removing the outer jacket and exposing the braid or shield. The braid should be cleaned to remove any dirt or oxidation, ensuring a good electrical connection. Fourthly, attaching the grounding hardware to the coaxial cable is a crucial step. The grounding block or clamp should be securely fastened to the braid, making sure that there is direct metal-to-metal contact. Fifthly, connecting the grounding conductor to the grounding point is necessary. The grounding conductor should be sized according to the NEC and be securely connected to both the grounding hardware and the grounding point. Sixthly, testing the grounding connection is vital to verify its effectiveness. A ground resistance meter can be used to measure the resistance between the coaxial cable and the grounding point. The resistance should be low, typically less than 25 ohms. Seventhly, documenting the grounding installation is important for future reference. The location of the grounding point, the type of grounding hardware used, and the results of the ground resistance test should be recorded. In addition to these installation steps, there are several best practices to follow when grounding coaxial cables. Firstly, always disconnect the power before working on any electrical system. Secondly, follow the manufacturer's instructions for all grounding hardware. Thirdly, use the correct tools for the job, such as a wire stripper, crimping tool, and torque wrench. Fourthly, avoid creating sharp bends in the grounding conductor, as this can increase impedance. Fifthly, protect the grounding connection from physical damage and corrosion. Sixthly, regularly inspect the grounding connection for signs of deterioration. By following these best practices, you can ensure that your coaxial cable grounding system is safe, reliable, and compliant with electrical codes. Understanding the specific requirements for RG-6 and RG-11 coaxial cables is also important. These cables have different shielding characteristics and may require different grounding hardware. RG-6 cable is commonly used for residential cable television and satellite installations. It has a thinner center conductor and a single layer of shielding. RG-11 cable is typically used for longer runs and higher bandwidth applications. It has a thicker center conductor and multiple layers of shielding. When grounding RG-6 cable, a simple grounding block or clamp may be sufficient. However, when grounding RG-11 cable, it is important to use a grounding connector that is specifically designed for the cable's larger diameter and multiple layers of shielding. The NEC provides specific guidelines for the size and type of grounding conductors that are required for coaxial cables. The size of the grounding conductor is determined by the size of the service entrance conductors. The grounding conductor must be made of copper or other corrosion-resistant material. The grounding conductor must be protected from physical damage. The NEC also requires that all metallic components of the coaxial cable system be bonded together. This includes the cable shield, the grounding hardware, and any metallic enclosures. Bonding ensures that all parts of the system are at the same electrical potential, reducing the risk of electrical shock. In addition to the NEC requirements, local electrical codes may also have specific requirements for coaxial cable grounding. It is important to check with the local electrical inspector to ensure that your installation complies with all applicable codes. Lightning protection is an important consideration for coaxial cable grounding, especially in areas that are prone to lightning strikes. Lightning can induce high voltage surges in coaxial cables, which can damage equipment and pose a safety risk. A lightning arrestor can be installed in the coaxial cable to divert these surges to ground, protecting the equipment and the building's electrical system. The lightning arrestor should be installed as close as possible to the point where the coaxial cable enters the building. The lightning arrestor should be properly grounded to a dedicated grounding electrode. Regular maintenance is essential for ensuring the long-term effectiveness of a coaxial cable grounding system. The grounding connection should be inspected regularly for signs of corrosion or damage. The grounding conductor should be checked for proper size and condition. The ground resistance should be tested periodically to verify that the grounding system is still providing a low impedance path to earth. Any problems with the grounding system should be corrected promptly to maintain its effectiveness. The purpose of cable entry seals is to prevent moisture and insects from entering the building through the coaxial cable entry point. Moisture can corrode the grounding connections, reducing their effectiveness and potentially creating a safety hazard. Insects can also damage the coaxial cable and grounding hardware. Cable entry seals are typically made of rubber or silicone and are designed to fit snugly around the coaxial cable. The cable entry seal should be installed properly to ensure a watertight and airtight seal. When selecting a grounding method for coaxial cables, there are several factors to consider. Firstly, the type of coaxial cable being used, RG-6 or RG-11. Secondly, the location of the grounding point. Thirdly, the environmental conditions. Fourthly, the applicable electrical codes. Fifthly, the budget for the grounding system. It is also important to consider the ease of installation and maintenance when selecting a grounding method. Some grounding methods are easier to install and maintain than others. The choice of grounding method will depend on the specific requirements of the installation. Ultimately, the goal is to provide a safe, reliable, and code-compliant grounding system for the coaxial cables. Proper grounding of coaxial cables is an essential part of electrical safety. A well-designed and properly installed grounding system will protect people and equipment from electrical hazards and ensure the reliable operation of coaxial cable systems. The NEC Article 820.40 provides the requirements and guidelines to adhere to when grounding coaxial cables.